Welcome, Jeff. It's great to have you
Hi.
here today. Can you give us a brief about yourself and about your business?
Well, I am a design engineer for a telecom company out of Atlanta, Georgia. What I do is I draw maps, two-dimensional maps in AutoCAD Civil 3D. And these maps represent new cable routes for 5G and fiber optic networks.
Okay, great. So our first question for today, what is CAD?
CAD is a blanket term for any type of computer-aided design or drafting. That can encompass Autodesk, which is the most popular version of AutoCAD, but there's also other ones. Mac has a proprietary version of CAD. There's also many cheaper options that do just as well, but this is kind of the industry standard is Autodesk.
Okay, excellent. Okay, the next question, what do CAD softwares do for mechanical design?
Well, they give us the precision and the ability to really solidify that precision as opposed to hand-drawn, which you got to account for many factors in terms of flaws and drawing styles, and you don't get the real kind of accuracy that you would with numbers in a computer. They're going to be, if you type in 0.0, it's going to be 0.0. There's no deviation from that. So the real advantage is that accuracy and the ability to save exactly as it is. So as opposed to like photocopying or reproducing a drawing, there's going to be some, degradation of the image or a flaw in the copy somehow. So from AutoCAD, you can make the same print 1,000 times and it's going to be the exact same every time.
Oh yeah, like it's a technological thing better than the handwriting and the handwork.
Very much so, yes. It was often done in two-dimensional, hand-drawn back in the 40s and 50s. And one of the first things they did when they invented computers was figure out a way to make it applicable to architecture and design and manufacture.
Okay, very interesting. Okay, the next question, what is the difference between two-dimensional and three-dimensional CAD designs?
Well, two-dimensional obviously is, you could visualize it as looking straight down onto an object. So you would just see the basic flat details of it. A three-dimensional would be looking at it from like a perspective or an angle to where you would see the sides, the depth, the height of that object. And, it's a different style of drawing. AutoCAD or most CAD programs can do variations on both, but there are certain programs that do it a lot better than others.
Okay. The next question, what are geometrical parameters?
Geometrical parameters are any type of thing, try and think of the best word.
Just say it.
The spatial, like you have to, oh boy, I had a good answer for this and now it's just disappeared. The spatial guidelines that you give a drawing, saying, a foot or a mile, we're doing this in metric, or we're doing this in imperial. 1 inch equals, 1 foot, or 1 inch equals 50 feet.
Like the measurement, for your drawing, you mean?
Measurement for the drawing, the scale for the prints. There's a lot of different parameters that you would need to give a drawing or a design.
Okay, can you give us an example?
Well, like when you're doing, you have two spaces in AutoCAD, in Autodesk AutoCAD, paper space and model space. Model space, for example, is 1-to-1. You can, if you draw a line and you tell it to be 10 feet, you're going to click on that line. It's going to say 10 feet. Paper space, though, is how you are going to print that drawing in on paper, obviously, but in a way that's very accurate to the drawing. Say, in this case, you would want 1 inch or 1 foot to represent 1 inch to be 50 feet or something. So like we draw in 1 to 50 in my industry. So when you look at the print that you print out, 1 inch on represents 50 feet actually in actual model space. So that's another example of a parameter that you would design, because there's also other scales that you can give it, 1 to 20, 1 to 1. And that's,
it depends on the scale and the size of the project. And
yes, exactly.
Okay. Okay, very good. The next question. What are the origins of CAD or CAM?
Origins of AutoCAD. Well, I was actually doing some research on the history of that myself. Turns out the General Motors design company back in the 60s was one of the first to really adapt to the new technology and use it in their design process to not only aid their design, but also the manufacturing process in terms of how they could maximize the process, the streamline the manufacture and reduce waste and flaws and really get a better example.
Raise the quality, you mean, of the work.
Yes, absolutely. And they were able to simulate things rather than actually, put something together, see how it works, go through that process. You can do it in a computer in a fraction of the time with, zero cost involved. So that was another early adaptation of it, was design or simulation of designs.
Yeah, okay. What are the advantages of CAD?
Well, the advantages, the accuracy, obviously, the ability to reproduce the same drawing, innumerable times without any deviations or flaws, the ability to transfer that file, that drawing, into not only a paper situation or paper printout, but also to transfer it into different file modes for different programs that could also utilize that information. It also is able to pull in information from, say, a spreadsheet like Excel. You can use that to help kind of guide the design and the process of manufacture within AutoCAD. So it is adaptable to a lot of different other software types and can utilize that information effectively.
Yeah, okay, very good. What are the disadvantages of CAD?
Well, the disadvantages are starting up. You have to basically know exactly what you're doing. Like you have to tell the program you were doing this in imperial or metric. You have to say 1 inch equals however many feet. You have to basically set up a world inside of an open file to be able to utilize that and be able to reproduce it in a way that's going to make sense to other people. So what a lot of times will happen is we will utilize things called templates, which is a file that has all the parameters involved. It's got the paper space set up, and all that we really need to do is start drawing in that, and it's going to come out exactly like we need it. Yeah. So you don't always start from a bare blank open page. Sometimes it's really better to have something already kind of set in stone to help you understand where you're going.
Sure. Okay, next question. What are wireframe models?
Wireframe would be, imagine a box that all you can see are the edges. And you can see through and you can see all the edges from your vantage point. Okay. From your perspective.
Like how does this work out in your work? Like what do you do with it?
Well, for that, that would be involved in like a 3D manufacture or a 3D design, which we usually do 2-dimensional, like staring straight down at something. But in say a situation where you're designing a part or even just a screw for some other larger device, you would basically draw that screw 2-dimensionally from all different sides, and then incorporate all three of those, all sides of that, usually 3 of them, into a wireframe, or not a wireframe, but a 2-dimensional or 3-dimensional representation in the corner of the drawing. Yeah, yeah.
Like you can see all the sides. You can look inside it, outside it, around it. Like it's quite similar to the realistic one.
For situations like that, you would be able to, like say this pencil sharpener, you would have a view looking straight down on it. You would have a view looking from the side, and from that, and there would also be in the corner a perspective where you could see whatever vantage point gives you the best ideal of the overall shape of the object. That would be not a wireframe. A wireframe would be able to see all the way through this, but like a kind of a surface model. So you can see all the sides as it would appear in the real world.
Mm-hmm.
Excuse
me. Yeah, it's okay. Okay, this drives exactly into the next question. What are surface models?
Surface models would be where instead of you see all the edges, you would see also the sides of it. You wouldn't be able to see directly through like a glass box. It would be like a solid box.
Ah, yeah.
It would have basically like an empty cardboard box. Mm-hmm. Almost would be a surface model. So you'd be able to see the sides, but you wouldn't be able to see all the way through it.
Yeah, like you are looking at a house from the outside, for example.
Yes,
yeah,
exactly.
Okay, very, very good.
Mm-hmm.
Okay, what are solid models?
Now, solid models would be, imagine looking at a box, but instead of it just being an empty box, it's solid all the way through. So if you were to design it with holes in it, you wouldn't be able to see the inside of the box. You would just be able to see the hole you designed, mm-hmm. as opposed to just an interior view of the box. So it would be like basically a lump of clay. Yeah. That if you poked holes in it, you would see the holes and not an empty box inside. If that makes any sense.
Yeah. Thanks. Like a SpongeBob, for example.
Yeah. Yeah.
Okay. What are the different types of file mode systems?
Well, there's a lot of different types of CAD systems, such as there's Bentley, which is a proprietary system used by some other telecom companies, which is radically different from Autodesk CAD. So one of the advantages that I think Autodesk really handles well is files like that into a mode that, say, Bentley could understand, or being able to take something from SolidWorks or CATIA and being able to translate that into a different drawing software. Okay.
Okay. The last question. Like you have used English for everyday communication, and you have used English also for your work, your technical area of work. Mm-hmm. What do you see the differences between the two types?
Well, engineering almost uses its own language. There's a lot of acronyms. Every different type of engineering has different terms. Like we use a thing called a handhole in telecom engineering, which is basically just a plastic box in the ground that you can put your hands in to connect wires if needed. And there's a lot of smaller, just sort of jargon within the industries that sometimes translates into the other aspects of engineering and sometimes does not. So you have to really be able to not only kind of speak your own industry's language, but be able to present yourself not simply, but engineers and aerospace would be able to have some.
Could you repeat the last piece?
Oh yeah, you need to be able to speak in a way that's not simplistic, but in a way that other, like say, engineer in a telecom or engineer in an aerospace field could understand your kind of the technical jargon without having to understand.
Okay, can you give us an example of a jargon word you use in your field?
Like coils, deboring, trenching. These are all just words. Coils are, for example, the extra cable goes a little further than needed to go a little further than expected, which we try to never do, but happens sometimes. Okay. So yeah, there's I'm trying to think of some other ones that are interesting, but it's not always not always a fascinating industry, unfortunately.
Okay, it has been so great to talk to you today. Sure, you will meet again soon. Okay.
Well, I hope I've helped, and I've really enjoyed this. Thank you for letting me be part of it.
Yeah, sure.